Okay, in this video I'm actually going to show you how to do the projectile motion type stuff in here. So this thing is coming in here, and in this problem it's coming in exactly halfway between these, right? So it's 4 centimeters here and 4 centimeters here, right? And what we want it to do is we want it to actually exit halfway down to this plate here. So it should displace itself downward 0.02 meters. Right, that's what we're going to do. So what we do is we set up our little horizontal vertical thing here. Right, so this will be our horizontal, this will be our vertical. S, U, V, A, and T. Right, and horizontally our displacement, right, we're looking at it while it's between the plates. So the horizontal displacement is 0.20 meters, right? It's actually 0.2000 meters, but I don't have the space to write it. Okay, our initial and final velocity in the horizontal direction is just this guy here, right? So our 4.2765 E7 meters per second, right? The acceleration in the horizontal direction is 0 because we're no longer accelerating horizontally. We're just accelerating actually vertically, right? And then the time we can figure out, let's see, vertically our displacement is that we want to go down 0.02 meters. Our initial velocity is 0. When it enters here, it's going perfectly horizontally, right? Our final velocity is, we don't really care. The acceleration is what we want to find, okay? So what I'm going to do is I'm going to find the time in the horizontal direction. I can find the time here by going x or s divided by v, right? So it's 0.2 divided by 4.2765 E7. Okay, so 0.2 divided by, and then I've stored this thing actually in my variable v, so I'm just going to go divided by that exact number, right? And I get that the time is 4.67, and then, you know, I'm not rounding at all, so it's 188, etc., etc. And I'm going to store that in my variable t, okay? So that's our time is 4.6767, oh, times 10 to the minus 9 seconds, okay? 6767 e minus 9, and that's the same time on the horizontal side, right? 4.6767 e minus 9, right? And now we can find the displacement here, or I'm sorry, we can find the acceleration here. I'm going to use s is 1/2 is ut plus 1/2 at squared, right? So let's see, 0.02 or negative 0.02 equals 1/2 a times that time, that crazy 4.6767 e minus 9 seconds squared, right? Okay, so what is it going to be? And you know, I guess I could ignore the minus. We know that it's going to accelerate down, right? Okay. Oh, and then if this is an electron, of course, the bottom plate would be more positive, right? Because we're going to accelerate that thing down, right? Okay, so hold on. Okay, so to do this, I'm going to go 0.02 times 2 to get rid of that, divided by alpha t squared, right? And I get the acceleration is 1.82888, or 88 times 10 to the 15th meters per second. Okay, now that is times 10 to the 15th. We can ignore gravity because gravity is going to add 9.81 to that. Okay, so yeah, that's well beyond our ability to, and that's meters per second squared, to discern. Okay, in the next video, I'm just going to show you how to get all the electrical stuff, how to get the force, the electric field, and the voltage.